only Japanese word I know, so I'll take the rest of the presentation in English. Sorry about that. So my name is Manyi. I run the MySQL optimizer team, responsible for query MySQL and the query optimization. So before I start, everybody raise their hands. Everybody, hands up.
皆さん、挙手お願いいたします。
Those of you who have tried 8.0, you can drop your hands now.
8をお使いの方は手を下げてください。
What? Wow, impressive. So, the people who have used 5.7 in production, drop your hands. There are a few using 5.6 in production, right? Okay, those of you using 5.6, drop your hands. Well, fantastic. So nobody is on 5.5 or before. Fantastic audience. I really like this. So I will walk you through the 8.0 features. I only got 30 minutes because I could spend days talking about the new features. So in the 40 minutes, I will give you some highlights. I will start with the MySQL features. So there are two MySQL features that we have added in 8.0, and those two make big difference for developers. I will start with CTE. CTE can be recursive or non-recursive. The non-recursive CTE is useful as a derived table, but it's really the recursive CTE that you can use it to do things that are not easy to do by other means. It's useful for traversing a hierarchy, like organizational chart. The syntax is like this. With recursive is the keyword. CTE is the name of the recursive CTE. As this is the definition of the recursive CTE. The definition has two parts. It has a select from table name. This is a seed select. So the seed select is non-recursive in itself. It will produce the initial result set. And once it's done, we put the initial result set into a temporary table. Then you can do a union distinct or union all. The difference is that union distinct removes duplicates. This is the part select from CTE table name. CTE is the name of itself. So this is the recursion part. We will run this recursion part repeatedly, and each time we put the results of this part into the temporary table. We'll keep executing this part until the select doesn't produce more rows. At the end, we do a final select CTE. This will give the result from the temporary table back to the user. So after we have introduced this feature in the early time of 8.0, we got some feedback. So what happens if a developer makes a mistake and forgot to define a criteria? So this recursion never stops. Or then it will run out of memory and crash the server. That's not good. So we introduced a safe measure called CTE max recursion depth. I think the default value is 1,000. So no worry, if a developer makes a mistake, they won't end up infinite loop. It will stop at 1,000 iterations. Now this is an example that shows how CTE works. We create a table, employees, with employee ID, name, manager ID, and now this have a foreign key on manager ID that references to employee ID. This part means that there's a hierarchy inside the employee table because the employee could have a manager, which is another record in the employee table. Then we insert some data into this employee table. We have Yasmina. She's the CEO of the company. She has employee ID 333. This field is null, which means manager ID of Yasmina is null. She's the CEO of the company. She has no manager. She's at the top level. Then you have John with employee ID 198, who has a manager ID 333, which means John reports to Yasmina, because Yasmina's employee ID is 333. Tarek also reports to Yasmina. Pedro, Pedro reports to 198, which is John, and Sarah reports to, I think it's, we'll keep going. Sarah reports to Pedro, because Pedro has employee ID 29. So I have a query. I want to know the reporting chain of every employee in the employee table. So each employee, I want to know who's, what's the reporting chain. So the query looks like this. The seed select that starts this recursion is select, the first part is employee extent. This is the name we give to the recursive city. It has 3 columns, ID, name, and path. And path is a concatenation of IDs. Then we do the select ID, name, and path from employees, where manager ID is null. This part starts recursion, and it will produce Yasmina. You can look at this as the content of the template table. Yasmina, this produces Yasmina because the manager ID is null, and Yasmina has no manager. She's CEO of the company. So this is the first result in the template table. Now we do union O. This is recursive select part. We'll do select SID name and concatenation of the path, which is this part. From employee extended and join employees S, meaning that we're going to join the employee extended with employee again. Employee extended doesn't mean the entire result in the template table. It means the result set produced in the previous iteration. In this case, we'll join Yasmina with the full employee table. And this iteration gives 2 more rows. It gives John and Terry, because both of them have their manager ID 333 equal to the Yasmina's ID. So those 2 report to Yasmina. Since this iteration gives a result, we'll keep executing this part and produce Pedro and Adriel, and they report to John and Tarek. And this will keep going until now in this iteration, Sarah and Pilar, they have no direct reports. So this query will return null, or return no records. Then the iteration stops, recursion stops. And finally, we have select star, order by path. So we'll do the sorting in the template table and return this result to the client. Okay, another MySQL feature is window functions. Window functions are useful for analytics, so more complex queries and reporting. Window functions are similar to aggregations, like grouping. The difference is that a grouping, they will collapse multiple rows into a single output row. Well, window functions will keep the rows as they are, but add an additional column at the end. Giving you one example of window functions. Now we have the employees in one department, or in multiple departments. We want to know that for for all employees, I want to know the name, department ID, and this person's salary, and the sum of the salary of all the employees in his department. And we want to sort by department ID and name. So over partition by, this is a keyword that illustrates some salary is a window function. So the result of this would be something like this. Null, department in ID null means it's a separate section. Then we list for department 10, we'll list employees Doug, Ed, Fred, Joe, Michael. And their respect salary is listed. In addition, the department total is a total of the salary in department 10. And the department total here is a total of department 20 and 30. A more advanced example is we introduce you to the stream concept. So similar as before, but now we want this partition to be partitioned by department ID, order by name, rows to preceding. This means that rows to preceding that we create a frame within the partition. So if we are at June, the partition would be rows to preceding, which is Ed and Fred. And in the way we do the total would be a total in this total for June would be the total in this frame. And this frame moves as we move down the list. Then, okay, we'll move on to the character set. So character set is a big change in MySQL because we changed the default character set, which used to be Latin 1 to Unicode, UTF-8 and before. And this will help MySQL's adoption outside of Europe. MySQL is commonly used globally in all countries. The default collation will be UTF-8, this collation. UTF-8 and before is the named character set. 0900 is the version of Unicode. So we support the newest version of Unicode, which is 0900. AI stands for accent sensitive or accent insensitive. CI stands for case insensitive. Addition, we support collations for more than 20 languages. I will show you an example of the Japanese collation. In addition, we also improve performance. So collation, what does it mean? Collation rules is used for comparison and sorting. Sorting is just another way for comparison. So we think that Japanese, we have introduced multiple collations for Japanese. The most commonly used one is we call UTF-8 and before, JA stands for Japan, and the version number is Unicode version 0900. It's called AS and CS. In the previous, the default is AICI. AI stands for accent insensitive, case insensitive. Well, the Japanese collation is accent sensitive and case sensitive. The reason for that, I'll show you here, is AS stands for accent. French, for instance, is accent. Japanese, it translates to this. So if you have haha and papa, because a hyphen mark is treated as accent sensitive. So if you use this default collation, well, papa and haha and papa will be evaluated as equal, which doesn't make sense in Japanese. And case sensitive in Japanese translates to the bigger character than smaller character. In this case, the beauty salon and the hospital, because those actually have different meanings in Japanese. But in the previous collation, they will be evaluated as equal. But in practice, it doesn't make sense for Japanese. So for Japanese users, I definitely recommend you to use a Japanese collation. And this is new in 8.0. In addition, for Japanese, we also have sorting order. And that Japanese sorting order is different from the European sorting order. In addition to this collation, we have introduced a kind of sensitive collation. So if you use this collation, hiragana and katakana characters will be evaluated as equal. In some cases, in some applications, it's good to use a kind of insensitive collation. But in some other cases, depending on your application, you may want to use a kind of sensitive collation. So it is comma, here, so comma. In this collation, we will sort hiragana characters before katakana characters. So we have spent quite some time improving the Japanese, because the Japanese is a very important market for us. And if you have more requirements, I'm more than willing to answer this. By the way, I'm the writer behind this sushi and beer blog, which I was told is well known in Japan. So before I continue, we want to do some more on the Japanese character set, because I want to know if we have introduced the Japanese character set over 20 years. I want to know, we are giving you the UTF-8 support, but can I remove some of the other character sets that I don't think is in use anymore? So I'll do this exercise. Raise your hands. How many people are using UTF-8 and before? Hands up. UTF-8 and before. Fantastic. That's the majority. Then, who is using Shift.js? Shift.js. It's one of the older industry standards in Japan. Well, 2, 3, 4, okay, 5. Come on, you can raise your hands. Don't be shy. There are 10 or so. So out of those 10 using the Shift.js, how many are using the ancient, really old, the SJS? Nobody using it. So how many are using the more newer CP932? Okay, some people are still using that. Now it's your chance. If you don't raise your hands, I will remove the character set in the next MySQL version. Now I get it already. So then also the EUC. So it's time to speak up. How many are use the EUC Japan? Okay, there are still people using it. Out of you, now keep your hands up now. How many of you are using the old UGIS collation, character set? It's a really old one. How many are using this EUC GPMS? Oh, that's good. How many people don't know what I'm talking about? Oh, everybody knows. So my goal is to enhance UTF-8, because obviously 90% use UTF-8. If you are using the old character sets, you need to let us know. We'll keep those untouched. But there's nothing I'll do on those. But if there are character sets that nobody is using, why add keeping them in MySQL? I will remove them. So we'll shrink our binary. So you will hear more blogs from us going forward about our proposal for deprecation. And please give us feedback. Okay, let's go back to JSON. JSON, since so many of you are familiar with 5.7, 5.7 introduced the JSON data type. It's a binary data type. You can always store JSON in a text or varchar, but the binary data type has two big advantages. One is it does a validation and insert, so we make sure the JSON you insert into the JSON column is valid JSON. And second, the most important part is it's optimized for select. So when you insert the JSON data into MySQL, we will parse it and create the binary representation. And in this representation, there is a header with all the keys in sorted order. So if I, in this case, want to do a search a name, select a name, I don't have to parse the entire JSON document. I can do a lookup, a binary lookup in the header, and then look up the value of name. this will speed up select statements drastically. We also introduced a lot of JSON functions. Those are introduced in 5.7. These are introduced in 8.0. But however, because JSON is so popular in 5.7, we backported those in 5.7. The only difference, the JSON table, is a big feature in 8.0. So the most commonly used JSON function you will encounter is JSON extract. In this example, the JSON extract will extract the name field from the JSON data, JSON document. And this extract is so commonly used that we introduced an operator for it. So this means we'll extract the name field in the JSON document called data and check it against if it's equal to gen. And this shorthand can be used in view definition, in DDL statements, and select, of course. JSON table is something we learned from our users. Because after 5.7, many people came to us. One, they want to use JSON as a data type. Because JSON gives flexibility. You don't have to have schema. But on the other hand, their query the business logic are complex. It's beyond insert, delete, update. They want to do grouping, aggregation, everything that you're used to do in SQL. So that's where the JSON table comes in, because it translates a JSON array to a relational table. For instance, we have a create table with a JSON column called JSON. And we insert some values, which is array of John with John's address, and Sally Brown, and John Johnson. And now, I want to map what we have previously, this JSON array, to a relational table with two fields, name and address. What we do is use a JSON table. JSON table specifies the JSON column, where I'll find the arrays, and then defines the columns. The columns will be name with varchar 40 as data type, address with varchar 100 as data type, and the path is where do I retrieve the name from this JSON array. And this JSON table will give me exactly this. So JSON table will return a result set, or if you use select into, it will map into a table. Once you map into table, you can use it in your select statements or other statements. Example for using JSON table is, I want to find all the people in the JSON array I had before who has name like John. JSON table will map to the mapping as before, and this part was just filtering, which returns this result. Then you ask me, the example I showed you so far is easy because it's array, it's flat. JSON by nature means it can be a nested document. It could be arrays inside arrays. How do I do this flattening? So example here, I have an array of families. Family 1 has father John and mother Mary. They're married, they have marriage name. Then there is a nested array inside this array. Then this array is named children. And family 1 has 2 children, Eric and Ben. And family 2 has 3 children. And this children is array. So this is a top level array of families. And within each family, we have a nested array of children. The result I want to get is on this hand side. I want each row for each element in the inner array. So there will be 1, 2, 3, 4, 5 rows because there are 5 children in 2 families. how do we do this? The JSON table specifies we want to take the JSON the family is a column name, and we want to define following columns: ID for ordinality. It's automatically assigned to each element in the top array. So John family 1 will have ID 1, and the father is varchar 30, and then married is an integer field. Exists path means if the marriage date at a root level exists, is 1. If it doesn't exist, it's 0. Then we have the nested path. Now we're saying that, okay, this nested array within the top level array. This nested array starts with is for the children field. It has 3 more columns. Child ID for ordinality. Now for the first child in the first family, Eric, it gets child ID 1. Beth gets 2. But for the second family, we start from 1 again, because Sarah is the first child in the second family. And this will keep going. In this example, now I've flattened out the nested array. I want to do more complex queries. I can do more complex queries. I want to know, for each father, how many children the father has, and the average age for all of his children. So it's father, count star, and average. That is because the from clause has this JSON table. This JSON table will produce the MySQL relational table like this. And once we have it, we can do a group by ID and father and select do the aggregation. This is not something you can easily do in other NoSQL databases. So JSON table leverages the very fantastic infrastructure we have in MySQL for aggregation and grouping, and we can use it on JSON data. So the indexing options you have is in 5.7, you can index by using a column name, add a virtual column, and add index on that. Now I'm talking about something that's not in 5.8.0 GA, but you will have it later on. Since you are here in Japan, I want to give you some hint. What's coming? So in addition to this virtual column definition, in 8.0 you don't really need to define the virtual column. You can just add a functional index. It's a functional index because the index name is, this specifies the type, varchar 30. And this is a function used to create this index. So what is this used for? Why do I do this? It's because array is very commonly used in JSON documents. But array has the property that they map array, so multiple values, to the same base record. And that's what we call a multi-value index. And this syntax gives me a possibility to say that I want to create an index on array, and this array is varchar 30. To show example, let's go back to the family example. We have 2 elements, 2 families as before, and now we add eyes color. So each child has an eye color, blue, green, brown, whatever. Then I want to do an outer table. I want to add an index on eye color on this field. And this is an array of varchar 10. The type of index is array of varchar 10. The index I'll get is something like this. Index are always sorted. So the eye color means eye color blue. This one, Eric has eye color blue. ID is primary key of the family 1. And brown is because Sarah has brown eyes, and the ID is family number 2. And we have green eyes because Beth has green eyes, and Nora and Peter in family number 2 has really nice. Now I want to use the index I have created. I want to know all the families who have a child with brown eyes. Then the optimizer will use this index and check, okay, brown eyes. Family number 2 has brown eyes. I look up 2, I do look up in the base table, this will listen 2, Paul and Laura. This index is different from the other index we have because multiple, like blue and green, multiple records in the index can point to the same record in the table. And that is special for our index. Also, we introduced JSON overlaps. It's because now I want to have a query. I want to find all the families with children of either blue eyes or brown eyes. Then we can do either blue or brown. That would be family 1 and 2. So I will return both records. This will speed up queries involving arrays drastically. Okay, let's move on to something not MySQL, more on performance side or management side. Invisible index is very useful because most people in the room perhaps are DBAs. DBAs has a common issue that maintaining an index has a cost because it has cost inserted and update. Sometimes DBAs suspect this index is never used. I really want to remove it because removing it means that insert speed will be better. But he also has a concern that there could be some seldom queries that use this index. And if I remove the index, the query will be worse. So now you can you do an alter table, alter index invisible. This means that the index is still maintained. So when you do insert query update, we'll still maintain it. But on the other hand, if we optimizer won't see this index, so when we do query optimization, we will execute the query as if there's no index. So DBAs can check if we make the index invisible, it's no performance drop, we drop the index. If there's a performance penalty, we'll just enable index by setting it visible. And turning index to visible or invisible is an instant operation, it's a metadata change. Another thing we did is, so optimizer to optimize for queries, we need statistics. One kind of statistic we will get in 8.0 is where the data is. The data can be in hard disk or in a DB buffer pool. Retrieving data from a buffer pool in memory and retrieve the data from disk means we use a different algorithm optimized for memory access or disk access. Now we have a statistic on if the data is in memory or not, we can choose the most optimal query plan. I'll show you one example. You do not need to understand this query. But you need to understand it's a complex query that is joining many tables, 8 tables. And there's a high selectivity field. So to make it simple, there are roughly 2 possibilities. So plan A means a query plan A or plan B. If the data is all in memory, choosing A for this complex query takes 5.8 seconds. However, if the data is disk bound, choosing this data will take 9 minutes. Plan B is the opposite. It's very slow in memory, but it's quick on disk. In 5.6 and 5.7, we don't know, the optimizer doesn't know if the data is in memory or on disk. So in plan B, it chases different plan because it doesn't have the data, the statistic. 8.0 will choose plan A when the data is in memory, and choose plan B with the data is on disk. So optimizer will be able to make the intelligent choice based on where the data is. And optimizer takes statistics, column level statistics, like how many records in each key, for each key, from the index in before 8.0. That's the only option. In 8.0, we give you another option called histogram. Histogram has advantage of you can calculate a histogram using the analyze table whenever you want. For instance, you have late in the evening, there's little load in the system, you can create the index create the histogram. Because histogram does a table scan, so it's a relatively heavy operation. So you need to choose when to do it. You can also enable this, and then the advantage is there's no cost on the insert speed or update speed. So if you add the index, it has a cost on the insert delete update load. But histogram has no influence on that. It's something you create maybe once, a daily basis or monthly basis or weekly basis. But it's a bigger operation. Let's show you example why it's important. So I will have this query. We join the customer with orders. We want to find the customers and orders that has customer has account balance less than minus 1,000, and the order date is before 1993. Possibly and possibly keys means order date. So this column has index on. This means that we can optimizer has distribution data on this order date, and it assumes it estimates 31% will fulfill this condition. On account balance, there is no index, so optimizer doesn't know anything. Then it assumes it's uniformly distributed. So the order date will be orders join customers, because the orders has a smaller filter rate. The basic strategy of optimization is for join is you join a smaller table with a bigger table. You always start a small table. So the join table is like this. And now we do an analyze table. And then we create a histogram on this account balance, which is no index. And we run exactly the same query. Now this gives a totally different plan. The join order is customers with orders. That's because the filter rate now is 0, because now we have statistic on no customers has account balance less than 1,000. And of course, optimizer will choose the table customers because no customers will satisfy this condition. So this query will actually give you zero result set. And what's the performance gain? In the first case, without the histogram, we'll join orders to customers. This is a response time, 15 seconds. And if you do the customer to orders, exactly same query, and the response time is down to 1 second. It's just because optimizer has chosen a different order, join order. And it's chosen that order because it has more statistics. Okay, that is my presentation. I can take some questions. Come on, no questions? You don't need to be shy. I mean, although we're in Japan, you can ask questions. No? Okay, come on, yes. Oh. Does it work? Does it work?
In
Yep.
Japanese.
Yep. Oh, okay.
JSON テーブルを作った時なんですけれども、毎回テーブルは生成されるんでしょうか。
Someone translate for me. I heard JSON table. I know something about JSON table. Oh, okay, it's all this kind of translation. Oh, okay.
Again.
Sorry about that. So, can someone translate again? I don't hear anything, so can someone translate?
JSON テーブルを、JSON、JSON 関数です。JSON、すみません、僕もテンパってます。
Yeah.
JSON テーブルが、
そうです。毎回テーブルを作る。
I don't get it. It's okay. It's a JSON function, right? There was a question on JSON function, I think. On those?
Yes.
Yeah.
テンポラリーテーブル作るかっていう話じゃないですか。
Okay, can someone repeat the? Okay.
ごめんなさい、質問もう一回お願いできますか。こちらで訳し入れます。
JSON テーブル関数で、毎回そのクエリを発行するごとにテーブルを内部で作ってしまうんでしょうか。それともなんかキャッシュとかをしてくれるんでしょうか。
So when executing JSON table,
Yep.
whenever we run JSON table function,
Yep.
will it generate a temporary table
Correct.
somewhere?
Yes, a temporary table. And if you want to materialize the temporary table into a real table, you can do a select into. Select into will create a table for you.
もし永続化したい場合には、セレクトイントゥですね、セレクト文には後ろにイントゥつけて、既存のテーブルに対しての格納をすれば、永続化できないことができます。
Yeah, yes.
巨大な JSON とかを読み込ませると、当然パフォーマンスへの影響があるんでしょうか。
So they're concerning about the performance overhead having the large amount of JSON document. Do we have any paths on the?
Yes. We did very good question. We did one performance optimization for update. With no support partial update. This applies to a larger document. For in the old days, if we need to pull the whole document into the server, change a little bit and put it back. But now in 8.0, if you need to change the telephone number, for instance, a small field in a large document, we only take that page into the server, change it, put one page back. This has a big performance impact for changing a small field in a large document.
参照系のテストではないんですが、更新系のテストの中では、JSON データがそのものの改良として、一部分だけ更新できるという機能を追加しています。でこれ、今までの MySQL 5.7 では、大きな JSON ドキュメントのうちの仮に一部しか更新しなかったとしても、ドキュメント全体を洗い替えるような動きになっていたんですが、MySQL 8.0 からは、変更した部分のみを内部的に変更することができるようになって、これがサーバー内だけではなく、サーバー間、全アプリケーションになりますが、を含めて、部分更新だけでの反映ということができるようになったというのが 8.0 での改良点でもあります。
ありがとうございます。Thank you.
Thank you. Okay. If you have more questions, you can just come to me afterwards.
あと、イベントの最後でもですね、Q&A の時間を設けておりますので、こちらでもご質問をいただけますし、休憩中などにも捕まえていただくことができるんですが、すいません、タイムテーブルを後ろに置いてきて、今、タイムパニックなんですが。
11時20分、次がマイクのセッション。
じゃあ、最後にもう一つだけの質問、はい、お願いします。
ヒストグラムのパフォーマンスですね、質問なんですけど、実際のテーブルの何%ぐらいをトピックするんですか？
サンプリング。
Sampling, good question. I think I answered the sampling for histogram. I understood it. the sampling is done in such a way that it's done in the handler level. So we still do table scans at the moment. Then, but when we, at the handler level, we jump. Like we only look at the 10th value we retrieve from the InnoDB. So that's the sampling part. It's quicker to build the histogram, but it's less accurate. But that's one step. I want to, going down the road, I want to do more sampling in the engine level. So I don't have to do the table scan. I can just scan quickly by doing InnoDB, doing the sampling. It's even quicker.
So right now server is doing something?
Now today, server is doing sampling at the handler level. So InnoDB retrieves this data. We look at our 10th or 20th record.
Can we adjust the sampling rate? I mean,
I think you can. I think you can. But there's even more optimization I want to do on that exam.
まずヒストグラムのところですね、サンプリングをベースにもちろん、統計情報を作っていくということはやっております。でその上でなんですが、サンプリングの比率の調整、確かできるはずっていう回答をしておりました。それからもう一つ、今の時点ではサンプリングの処理を、ハンドラーレベルですね、ストレージエンジン共通のレイヤーのハンドラーレベルでやっているんですが、これをInnoDBストレージエンジンのネイティブのですね、ストレージエンジン側でサンプリングをすることによって、スキャンするところの処理を減らして、より高速にですね、サンプリングができるようなことを今、次の改良としてやっているところでございます。よろしいでしょうか。はい、ありがとうございました。ではですね、以上をもちまして、Manyiからのセッション、終了とさせていただきます。